So let's go with some more VLSM examples here with some B class requirement. So in this example, I'm not going to use the complete step-by-step method. I'm going to use a shortcut method. So my requirement here I have given here. I got a network size with a 4000 host, with 1000 host, 500 and 200 host. So I want to write down the range, and as they are in different sizes, I'm going to use some VLSM. I need to write the range with subnet mask. That's my requirement. Okay. So to make this possible, so first we need to go with some higher requirement here. So I'm going to start with 4000 requirement here. So requirement of 4000 host. So when I have a 4000 requirement, what is the nearest value, power value satisfies my condition? So check for the 2-port table. In the 2-port table, 2 to the power of 12 satisfies my condition. That's 4096. So I'm going to take 2 to the power of 12. 4096 is the possible size of the network. So whenever you are writing the range for the bigger numbers, if you go back to the B class examples, what we have learned, so we always use a formula of 2 to the power of h, right? 2 to the power of h divided by 256. So I'm going to use 4096 divided by 256. How many blocks of addresses are required for 4000 addresses? In 1000 I get 4, in 4000 I get 16 blocks. So I need 16 blocks of addresses required for this to write the range for 4096 addresses. So let's write down. So what is the size of the network? 4096 is the size of the network because of 2 to the power of 12, I think, right? 2 to the power of 12 is 4096, 112048, yeah. And the range starts from 0.0, and I need a group of 16 addresses, that is plus 16 here. So which means it will be 16.0 will be the next network, and my networks ends on 15.255. And the slash value will be slash how much? From 32 if I subtract 12. Let me write down here. To get the slash value, I need to subtract from 32. If I subtract 12, I'll get slash 20. So slash 20 is your network bits. So I'm going to take slash 20 here, slash 20. So this is my first network. Now my first network starts from 0.0 to 15.255, and it's going to provide me somewhere around 4096 addresses. So it's a group of 16 blocks, 0.0 to 15.255. Now similar way we need to do the same thing in the remaining examples also. So let's take the next requirement. My next requirement is how much? It's 1000. So 1000 means the nearest possible value which satisfies my condition is 2 to the power of 10. 1024 will be the possible size. If you check the 2-port table, 1024 is the nearest possible size. So I'm going to take 2 to the power of 10, which means my host bits are equal to 10. And how many blocks of addresses were required? So 1024 to the power of h divided by 256. I need 4 blocks of addresses. Okay, so 4 blocks of addresses are required in order to get my 1024 4 blocks. Okay, so which means to write the range I need 4 blocks of addresses. So as per this example, I need 4 blocks of addresses. So I am going to take the 2 to the power of 10, that is the size of the network is 1024. So I need 4 blocks of addresses. It's going to be plus 4. So which means the next size will start on 20.0 and my range ends on 19.255. So I need 4 blocks of addresses, 16, 17, 18, 19. And the slash value will be slash 22. Slash 22, because here you can see the host bits are 10. From 32 if I subtract 10, it's going to be how much? Slash 22. So the same slash value I'm writing here. Okay, so this is the next size requirement. So my next size is from 16.0 to 19.255. It's going to accommodate around 1024 addresses, which is a group of 4 blocks of addresses. So here let me write down here also what is the slash value from 32. If I subtract 10, it's going to be /22. Okay, so this is my next, and after that let me just come down here a little bit to find the remaining values. So I'm going to find the remaining values here. So the remaining values will be what's the next requirement? The next requirement is 500 host. So the requirement is 500 host, and what is the nearest value satisfies? 2 to the power of 9. 512 is the possible size which satisfies my condition. You can see 2 to the power of 9 is 512, and then 512 means I need 2 blocks of addresses. So if you just divide 512 divided by 256, so if you just do this, you need 2 blocks of addresses. And then what is the subnet mask? Subnet mask will be from 32. If I subtract 9, it's going to be /20 20 23. So that is my subnet mask. So this is the subnet mask, and then the blocks of addresses is the next calculation. So I need 2 blocks of addresses in order to accommodate 512 addresses. So it's going to be 2 to the power of 9. 512 will be the size of the network. I need 2 blocks of addresses, so it's going to be +2 here, and the next size starts on 22.0, which means my range ends on 21.255 with a /value of 23 /value of 23. So this is my next size, which starts from 20.0 to 21.255, a group of 512 addresses which needs 2 blocks of addresses. And the last requirement is how much? The last requirement is just 200 host. 200 means 2 to the power of 8. 256 is the possible size which I can divide. So which means 2 to the power of 8, it will be 256, which means I just need only 1 block. And the subnet mask will be from 32. If I subtract 8, it's going to be /24. Now here you can see in this example, this is your equal to C class example, but it is not C class. So don't think that when you have a /24, it's going to be C class, but it's going to be a B class network only. But after dividing or after subnetting, the size of the network is equal to C class. Okay, so mostly the subnet mask, the range will end on 22.255, because when you're starting from 22.0 to 22.255, we get exact 254 or 256 addresses, and the /value will be /24, the more equal to C class. Now here, this is how the range will come here. Now the range is always written based on the size of the network. Now based on the size of the network, we need to increment the values here. Now one thing we need to remember here, when you are incrementing the values, let me just take an example here. Now the incrementation of the values is completely based on the size of the network. So the increments, whatever we are doing, it totally based on the size of the network. Okay, so let's take an example. In our C class examples, which we did in the basic first examples, whenever your network requirement is less than or equal to 128. Okay, so let's say we got 4 portions, x dot x dot x dot x. So we always increment in the 4th portion, because in one portion you can have not more than 256 addresses, starting from 0 to 255. Okay, so in one portion we can only have 256 addresses. So which means if your network size is less than 128, we always increment in the 4th portion. So if my requirement is greater than or equal to 60, so if my requirement is greater than or equal to 256, even if you take the network requirement is 256, let's say you got 4 portions, we need to increment on this portion, the 3rd portion, because if your network size is 256, then the range will start from 0.0 and ends on 0.255, which means the next range will start from 1.0. So which means it will be increments of 1. So if your network size is 512, it will be multiples of 2, because we need 2 blocks of addresses for 512. If you're using 1024 addresses, we need 4 blocks of addresses, which means the increments will be +4 here. And if you have a network size of 2048, it will be 8 blocks. Like that it will go on, +8. If your network size is 4096, it will be 16 blocks, +16, something like that. So whenever your network size is greater than or equal to 256, we always increment in this portion. And if your network size is greater than or equal to 65,536, in that case we need to increment in this second portion here. Why? Because when we are incrementing, when your network size is 65,536, which means it is 2 to the power of 16, which means these two blocks are not sufficient, because the size of the network is how much? 65,536. In that case only we increment here, which is not generally common. You don't find this such a big networks, but this is how we need to remember. So the increments, it's always based on the size of the network what we are using. In case of any class, whatever the class you do subnetting, it can be A class, B class or C class.